The rock art database, centralizing and streamlining heritage using the CDOC reference model. The rock art database is a rock art heritage project at the Place, Evolution and Rock Art Heritage Unit at Griffith University. It is designed to bring members of the greater rock art community together in one centralized global network to discuss and share rock art information. The platform functions as a hub, including data repository and data visualization tools in rich media content. The platform further encourages users to contribute to the system, share digital datasets, and assist with streamlining rock art data. This paper discusses the implementation of the CDOC reference model in the rock art database. It looks at data ontology, metadata management, and technological advancements in collaborative cyber environments, exploring relational and hierarchical structures of planning, recording, managing, monitoring and disseminating data from World Heritage to national and local projects. The paper is concerned with identifying knowledge gaps within the CDOC model and existing rock art management systems. The project currently focuses on Australian rock art, but it is not limited to Australian rock art. To get started, I would like to take you on a brief journey through the World Wide Web and look at state-of-the-art heritage projects. The leading authority in heritage management is, of course, UNESCO. If you look at the World Heritage List website, we can find over 1,000 heritage places. Places are categorized in cultural, natural, and mixed sites. If we work our way further through the system, we can find lists by country, region, or latest entries. UNESCO's sites are not centrally managed, but rather individual projects feed into the World Heritage List to provide a global oversight. Other projects include the Global Heritage Network, which provides a list of several hundred heritage sites around the globe. The website allows the user to browse visually through heritage sites and provides information through text and image on the management and conservation status of sites. The Global Heritage Network utilizes the Google Earth framework to allow for an interactive display using layers of KML files. Another project concerned with the visualization of heritage sites is SciArc. SciArc aims to build 3D models of important heritage places around the world. The archives mainly concerned with 3D imaging and only provide very little information on the sites themselves. Last example of heritage management and visualization attempts is the Google Art Project. The project, now under the Google Cultural Institute, encompasses museums, art galleries, images, paintings, and heritage sites from around the world. Here's an example of a rock art site in Australia listed by Prow at Griffith University. The entry allows users to browse through pictures or interact with image galleries and use Google Maps. While all these projects provide great examples of the use of new technologies and centralized approaches for heritage management, let's see how national systems compare to international and commercial systems. In this presentation, we'll focus on the use of Australian heritage data within the Australian heritage sector. First, let's take a look at the Australian Department of the Environment, the leading heritage authority in Australia. If you browse through the National Heritage Register, it is often difficult to find information. The register is difficult to use and only provides limited information through its search functions. Individual entries within the Australian Heritage Register are very limited, and information is often unorganized and difficult to find. The system is mainly composed of description fields and photographs. Other Australian heritage registers, for example state-based registers, have similar issues and are often inadequate to manage cultural heritage. This has been addressed through the State of the Environment reports, which every year express their concerns regarding adequate heritage management systems in Australia. The full extent of these inadequate systems can be seen in the ACT or Tasmanian Heritage Registers. The register consists of simple Excel spreadsheet. The spreadsheet can be downloaded from the Heritage Authority website and provides no more information than address, location, and the name of the site. But let's move on to rock art heritage. How are rock art sites managed across the globe? Of course, we have local or regional archives such as TARA, the Trust for African Rock Art, SORADA, the African Rock Art Digital Archive, or ARARA, the American Rock Art Research Association. These archives provide information about regional rock art in image and text and often make rock art information available to the general public. There are currently hundreds, if not thousands, of rock art online presences with valuable information on local and global sites, but unfortunately most of these sites and systems do not communicate and are often not even able to share information outside of their own system. The Rock Art database tries to solve this problem through bringing together global rock art projects, sites, and even individual item entries through the integration of ISO standard 21127, the CDOC CRM. While a social network type database allows users to share and manage rock art data, the integration of the CDOC CRM provides an international standardized heritage framework that allows for improved communication and compatibility of data within the greater heritage sector. This includes compatibility with museum, research institutes, archives, libraries, and extends further into information communication technology, sciences, or humanities. Let's take a look at the current proof of concept model of the rock art database. The model has been deployed in January 2014 and has been tested over the last year for its compliance with the CDOC CRM and usefulness within Australian and global rock art research. The database currently consists of over 200 project entries and receives up to 40 individual visitors a day. Current entries are managed at Griffith University, but once the test phase is over, the system aims at allowing users from around the world to create user profiles and upload and manage their own content. We are currently looking at May 2015 for a complete rollout. The platform uses a GIS system and displays user information on a global map. Users can upload projects they are currently working on, for example, University Research Department project, publicly funded projects, commercial projects, community projects, or personal projects. Projects can include global rock art information, regional rock art information, for example, Australia only, or local information, for example, information about a particular site. Lastly, the system displays UNESCO World Heritage sites related to rock art. If we click an entry on the map, the entry gets highlighted and information displayed in the info window on the map. The info window includes profile information about project entry, classifications about projects, for example, site types, types of archaeology, excavations, and so on. Further, the user can browse documents, conferences, and newsletters to assist with more information about individual projects. Each entry also provides rich media content in image, video, and 3D. Images can be uploaded and shared through image galleries, giving image descriptions and titles. Videos can be uploaded and shared, but the system also allows to link existing, for example, YouTube channels to the database. This allows users to manage videos in one location only, for example, YouTube, and they do not have to upload videos in both YouTube and the rock art database. This is an example of some of the functions that make use of APIs in the rock art database. Other API functions include Flickr, Google Documents, and various social networks. The user can also browse interactive 3D content through the integration, for example, Google Earth, X3DOM, or Autodesk's 12 3D Catch. Using Google Earth allows 3D models to be placed in virtual environments and allows to contextualize sites within their natural surroundings. Other functions here include simulations, such as the day and night function or display of the night sky, which can be animated in a time-lapse-like fashion. This could allow for comparison of not only terrestrial objects, but the night skies as well. And of course, KML files can be directly loaded into these Google Earth models. Users can set up external accounts with, for example, Autodesk, and can display their 3D galleries in the RockArt database. This here is an example of my work desk where I'm currently putting this video together. Users can explore RockArt, in this case my desk, from different angles, allowing for identification of intricate grooves, but also view hidden angles that might not be visible from a standard 2D photograph perspective. Lastly, the system makes use of the latest X3DOM in HTML5, which allows dynamic display of 3D models across a variety of platforms from standard desktop to tablets and mobile phone devices. X3DOM can display models in layers, and users can interact with the models, changing, for example, lighting, but also textures. Each entry can of course be searched through a comprehensive search mask. The search mask can be used to find information, but profile holders can also use it to generate comprehensive reports. Let's look for any entry that includes, for example, the keyword UNESCO. In the bottom half of the window, a slideshow appears that now allows users to not only browse the map, but also visually browse individual entries. Keep in mind that we are looking for UNESCO as a keyword and not for UNESCO-specific sites. This is why we can see a range of entries in the search results section. If we select, for example, a specific site within Kakadu National Park, we can see that the entry is part of a particular project and provides individual information about the site in image, video, and 3D. But let's look at a different section within the RockArt database. When users create a new project, site entry, or even just upload a new document, they can post this as a news entry. This is similar to a news feed in Facebook. The difference is that not all information is news, but the user can generate these news entries individually. Here we can see new entries in Australia, for example. The latest entries also get listed within a news type list. On the right-hand side of the news section, the latest newsletters as well as the latest conferences are displayed. These entries are directly linked to user projects. If the user decides to share their latest newsletters or upcoming conferences, this gets displayed here. This was a brief overview of the front end of the RockArt database, but what about the back end? This is where the CDOC CRM comes in. Each data field has been linked to a specific entity within the CRM. Here's a brief overview of the CDOC CRM. The CRM is a reference model intended as a guide to assist with the development of heritage management systems. Using the CRM allows for data to be not only compatible with other international systems, but also ensures flexibility for quality assurance and future proving. The CDOC CRM is currently used by UNESCO projects, ECOMOS projects, but also Archist and many more. It is put together by archaeologists, heritage professionals, but also scientists such as physicists or IT professionals. The idea is to create a system that allows to work in a variety of disciplines while maintaining a communication standard that allows for everyone to be understood. This CRM consists of entities and attributes that inform the design of the RockArt database system. Mapping RockArt and the CRM allowed for more detailed understanding of global RockArt management problems by using an international standard that allowed for comparing the classification of individual project entries.